In this video, we will calculate a two-sample z-test for proportions. Let's go ahead and read the problem. During a vehicle crash test, a car manufacturer compares visual damage of two car types in a 10-mile-per-hour crash test. For car type A, 19 out of 100 cars sustained no visual damage, and for car type B, 22 out of 100 sustained no visual damage. We want to know, is there sufficient evidence to claim that type B cars do better in the 10-mile-per-hour crash than type A cars? We want to use a significance level of 0.10. So let's go ahead and give our null and alternative hypotheses. So the null hypothesis is always a statement of equality or no difference. So our parameters here are PA and PB, so the true proportions from these two car types. And this will be equal to 0. The alternative hypothesis now will reflect our question of interest. So if the type B cars actually do better, what that means is that the proportion of cars that don't sustain damage or visual damage will be larger than the type A cars. So this will mean that the proportion, the difference of these two, will actually be less than 0. It'll be a negative number. So this is our null and alternative hypotheses. We should always make sure that our samples or our trials are random, and in this case it's more of an experiment, so we have random trials. And we need to have a large enough sample size. So in this case, we need to know that the number of successes and failures for each group are greater than or equal to 10. In this case, the successes for the car type A is 19. The failures are 81, which are both greater than or equal to 10. And for car type B, we have 22 successes and 78 failures, which are, of course, both greater than 10. So the sample size conditions are met. This essentially just means that the distribution of the difference of proportions is normally distributed. So we can use Z procedures instead of a different type of procedure. All right, so now we should calculate our Z test statistic, where Z is equal to P hat of A minus P hat of B minus our claim P hat or PA minus PB, which is just 0, all divided by the square root of, in this case, it's P hat 1 minus P hat. So it's a pooled proportion times 1 over NA, our sample size for the type A car, and the sample size for the type B car. And here where PA, this is our pooled proportion, is simply just the number of successes in each group added together divided by the total sample size, which both of these were 100. So this is equal to 41 over 200, which is equal to 0.205. So that's our pooled proportion. Why we use that is because always in a hypothesis test, we are assuming the null hypothesis is true, which in this case is that our two proportions are equal to each other. And so if they were equal to each other, then essentially that pooled proportion would be the same value for each one of our proportions in the true population. So here we have Z is equal to P hat A, which I'm just going to write over here is, again, equal to 19 over 100. So this is equal to 0.19. And P hat B is equal to 22, the number of successes over its sample size, which is equal to 0.22. So if we plug this into the formula, we get 0.19 minus 0.22 minus our claimed amount, which in this case is 0, all divided by our pooled proportion of 0.205 times its complement, which in this case is 0.795, so 1 minus 0.205. Times 1 over 100 plus 1 over 100. And make sure you bring out all your parentheses. This is equal to a numerator value of negative 0.03 divided by a denominator of 0.0571. So that's our standard error, which is equal to a Z test statistic of negative 0.5 0.255. So this is not a very extreme test statistic. If we were to draw our normal distribution, it would be somewhere here. If this was 0, this would be negative. I'm going to round this to 2 decimal places, so it would be negative 0.53, be somewhere there. We have a lower one-sided test, so the p-value that I'm looking for will be this area. That's probably going to be relatively large. So let's go over to the standard normal table and see what that value is. So if we go over to the standard normal table and we find our negative 0.52 and we scroll over 0, 1, 2, 3 columns, so negative 0.53 if we were around it, we get a p-value, or the area that falls below that, of 0.29806. This will be our one-sided p-value for this z-test. So this area is equal to 0.29806. That's a pretty large p-value. So let's go ahead and scroll down a little bit, make a conclusion. Again, the p-value is equal to 0.29806. This is, of course, greater than our significance level, which was equal to 0.10, so we will fail to reject the null hypothesis. And if we were to write out a conclusion, we would just say that there's really no evidence to support our alternative hypothesis. And again, the alternative hypothesis was that car B did better than car A in the crash test. And it essentially just didn't have enough evidence for that. The proportions are too similar.